Back at it, we're doing 7-4. Let's add and subtract some radical expressions. So when we have roots that are being added to one another, they have to have the same index and the same radicand, the same thing underneath the root symbol in order for us to combine them. Much like when you have a variable x squared and x squared, you can add those and subtract those, but an x and an x squared, you can't. Okay, so that's what we're looking for here. We're trying to simplify these as much as possible to see if there's anything that we can combine. So first thing, with the square root of 20, we need to see if we can split that into a perfect square and another factor. And we can. 4 times 5 is 20. Okay, well, what's the square root of 4? It's 2. So that leaves us with 3 times 2 times the square root of 5, which is just 6 square roots of 5. Okay, and so that one is taken care of. Then we will move to the next one, the cube root of 32. So is there a perfect cube that we could take out of there? Well, 2 cubed is 8, and so I think I can split that into 4 cube root of 8 times 4. And the cube root of 8 is 2, so that leaves us with 4 times 2 times the cube root of 4. 4, 8 cube roots of 4. Then we have 2 square root of 2. Can we simplify the square root of 2? Nope. So we just, that one comes down here, square root of 2. And then the last one, 3 cube roots of 4. Well, we already have a cube root of 4, which we know we can't simplify because our smallest perfect cube is 8. And so that one also just comes down minus 3 cube roots of 4. So our final answer involves combining like terms, 8 and 3. So that gives us 5 cube roots of 4. And then we have square root of 2 and square root of 5. So those have to stay separate. We have plus 6 square root of 5 minus 2 square root of 2. There's 15. Right, let's jump to number 16. 16 is very similar. So we have all square roots this time. No mixture of roots. So the square root of 32, we need to split that into a perfect square if we can. Okay, 16 times 2. And the reason I use 16 is because that's a perfect square. It comes out as a 4. So negative 5 times 4 is the square root of 2. Or negative 20 square root of 2. And that's taken care of. Then we'll look at the square root of 45. Okay, so can I take anything out of there that's a perfect square? Let's list all our perfect squares. 4, 9, 16, 25. And I'll stop there. So 25, no. 16, no. 9, yes. 9 times 5 is 45. So minus 5, what's the square root of 9? It's 3. Square root of 5, so minus 15 square root of 5. Done. Alright, square root of 8. Looks like I can take out a 4. So that's the square root of 2 times 4. Wrote those in the opposite order this time. Minus 2 square root of 2. Okay, and then 2 square root of 5. Can't simplify the square root of 5 at all, so that's going to come down here as plus 2 square root of 5. Alright, now we combine like radicals. So square root of 5, square root of 5. Negative 15 square roots of 5 plus 2 leaves us with negative 13 square roots of 5. And then minus 20 square root of 2 minus 2 more square roots of 2. Negative 22 square roots of 2. And just for fun, we'll put that answer up there. Negative 13 square root of 5 and negative 22 square root of 2. Alright, 17. This is where things get big. 6th roots. So let's say you get to a question and you didn't have that handy table waiting for you. what could you do? Well, you could do 6, nope. You could do 2 to the 6th, 64, 3 to the 6th, 729. You kind of make your own table, and you see it gets really large really fast. So unless these numbers are huge, it's not really going to help us. So the main one I'm looking at, or the only one I'm looking at, is 64 in this case, because none of our numbers are even smaller than 720, or bigger than 729. So with that knowledge, 2 to the 6th is 64. Now just see if I can divide any of my sixth roots, the numbers under there, by 64. So 384 divided by 64. Also, just let it be known, I didn't do 12 divided by 4 in the calculator for me. I know that one. Anyways, 384 divided by 64 is 6. So this can be split up into 64 times 6, which means that this one also can be split up into 64 times 6. Okay, and then 6th root of 9, that's not we can't take the 6th root of that without coming up with something irrational, but we can leave it there. And so I'll just bring those down. 5 6th root of 9 minus 2 6th roots of 9. Okay, now let's focus on the ones we can simplify. So the 6th root of 64 is 2. Comes out, we get negative 8 6th root of 6th. And I'm going to combine these in a second, but let's look at this one. We've got plus the 6th root of 64 is 2 again, so plus 10 6th roots of 6. And then 5 minus 2 is 3 6th roots of 9. Last step, combine those two more like terms. 2 6th root of 6 plus 3 6th root of 9. And we'll check ourselves. 2 6th roots of 6 plus 3 6th roots of 9. Alright, you really should try to say these things out loud. It's kind of tough. Okay, I'll do one more. Number 18 here. This one's easier than the last one. So we got some square roots here. So can we simplify the square root of 10? Well, can we divide it by 9? No. Can we divide it by 4 evenly? No. So 2 square root of 10. Simple as it gets. 3 square root of 2. Simple as it gets. This is fun. Okay, 5 square root of 40. We can do something with that. I think 8 times 5 is 40. But that doesn't help us. What does help us? 4? Oh, cool. 4 and 10. 4 times 10. So the reason 8 times 5 doesn't help us is 8 is not a perfect square, and neither is 5. But 4 is a perfect square. And then 2 square root of 50. Okay, well 25 times 2 is 50. Okay, so these first two, those are as simple as they get. Let's simplify this one. Square root of 2, or 4 is 2, so that's 10 square roots of 10. And the square root of 25 is 5, so 2 times 5 is 10 square roots of 2. So all these are as simple as they get. Now we just combine like radicals. So 2 square root of 10 plus 10 square roots of 10 is 12 square roots of 10. And then 3 square root of 2 plus 10 square root of 2 is 13 square root of 2. And that one also is as simple as we can get it. Let me erase that. I thought I was going to. And you see we figured it out. Alright, so that'll be it for this one. If you need more, just let me know. Be happy to do them.